Welcome. This video is going to step you through our 7-1 to 7-4 quiz review in case you have any questions along the way that you want to clarify. So the first set of 8 is all about just simplifying the expression that's given. So with number 1, to simplify the expression, the first thing I notice is those negative exponents. Okay, so I'm going to take care of those negative exponents first. So I'm going to move the 5 down, and I'm going to move the 3 down. Recall negative exponents mean negative attitude. You need to take care of those first. So next, 3 squared is going to be 9. So I'm going to rewrite that as a 9. Now multiplying two fractions together, on top 1 times 1, on the bottom 5 times 9 would give me 1 over 45. And that would be what I would deem as the most simplified answer for that question. For number 2, I'm seeing a power of a power. Remember, power of a power rule means we're going to multiply. Okay, so r to the negative 5 times negative 4 is just going to give me r to the 20th power. Number 3, I see 2 things being multiplied together. So remember, when you're multiplying things together, make sure you remember you simply multiply the normal numbers. So 2 times 3 gives you 6. And then remember, when you're multiplying like bases, you add exponents. So that will give you x to the 17. Looking at number 4, so the first thing I notice is that p to the 0. Remember, anything to the 0 power is just 1. So I'm going to scratch that off right away because multiplying or dividing by 1 doesn't influence anything. Okay, so that's just gone right off the bat. The rest of what I notice are the negative exponents. So I'm going to move anything with a negative exponent because remember that means it has a negative attitude, needs to make an adjustment. So the m is fine. The n is going to move down, and the q needs to move up in order to get positive exponents everywhere. Number 5. Okay, the first thing I notice about 5, b to the 0 power turns into a 1. Multiplying by 1 doesn't really matter. So I'm going to take care of that right away. And now I'm going to look at what I have left. Well, now I'm multiplying 2 things of the same base. Remember that rule, multiplying 2 things of the same base means you add exponents. 2 plus negative 3 or 2 minus 3 gives me a negative 1. Need to get it a positive attitude, so I'm going to move it down. Number 6, I see 2 different parentheses with a power of a power, okay? So I'm going to deal with those parentheses separately first. So 3 squared to the negative 1, power of a power, 2 times negative 1 gives me a negative 2. Then here, I'm going to apply that 3. So 4 cubed and m squared m squared cubed, power of a power, 2 times 3 gives me 6. Now I have some adjusting to do. So that 3 to the negative 2, remember it needs a positive attitude adjustment, so I'm going to move it down. 4 cubed is just fine as is, and I'm going to write that as 64. Again, if you need a calculator, that's totally fine. M to the 6 doesn't have to move either. Final step in cleaning this up, anytime you're dealing with numbers, I don't want you to leave that. So for example here, this 3 squared, I would want you to write that as a 9. I'm going to deem that more simplified. All right, number 7. First thing that I noticed, this whole parenthesis being taken to the 0 power. Again, 0 power is 1. Multiplying by 1 doesn't impact anything. So now I have it down to this. Power of a power. So I'm going to apply that -1 power throughout the parenthesis. So I get 3 to the -1, and 6 times -1 gives me a -6. And of course, now I have negative exponents. We need an attitude adjustment. So I'm going to adjust to where they are in my fraction. Move the 3 down, move the m to the 6 down. And finally, and I'm going to erase some of this so I have more space to work. Number 8. So number 8, first thing I notice is that 0 exponent. So that t to the 0 just becomes a 1. And again, multiplying by 1 doesn't change anything. And so now I'm going to apply those parentheses. So I'm going to start with this one, which is going to give me 3 cubed. T squared cubed. Power of a power is going to multiply to give me t to the 6. And then that gives me 2 to the -3. So now I'm going to do my adjusting. So 3 cubed, again, if you need a calculator, otherwise you can think of that as 3 times 3 times 3, gives you 27, t to the 6. That 2 to the -3 needs an attitude adjustment. I'm going to send it down so it can become positive. And again, whenever I have a number to a power, I will want to clean that up. So 2 cubed, you're going to call that 8 for me. So that is the end of the first set. So I'm going to erase this so we can move on and talk about some scientific notation. All right, so I want to write each of these numbers in scientific notation. All right, so remember, scientific notation. You look at your first significant digit and you're going to put your decimal there. So ultimately what I want this to be is 4.803 times 10 to some power. Okay? And so I'm going to take where my decimal is now and I'm going to move it that far. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I moved it 10. And I'm working with a very large number, so that means it's going to be a positive exponent. This next one, again, put your decimal after the first significant digit that you have, and now we need to see how many times I have to move my decimal to get it there. So I have to move it 1, 2, 3 times. But I have a very small number, okay? So it's not 3, it's going to be -3 that it moves. All right, number 11. So number 11, remember when you're multiplying in scientific notation, remember you take this value and you only multiply it to that first number, okay? So here, 0.3 times 2 is going to give me 0.6. And it doesn't influence the power of 10. Okay, remember you leave that power of 10 when you're just multiplying a normal number in. But there's a dilemma here, okay? The dilemma being that that number is no longer between 1 and 10, okay? 0.6 is too small. So really it needs to become 6 times 10 to some power, okay? I need to move that decimal over 1. Now, here, this is kind of the reverse of anything you saw in the notes we've done so far, where now we have a small number and we're transforming it. So because we're starting with a smaller number than we're ending with, small is going to take away from that power of 10. Okay, it's going to make it smaller because that's how you started. You started as a small number. Okay, so I'm taking away that power of 10. All right, so for number 12, that square, okay, that squared term is going to influence both pieces, right? Remember, power of a product, that power influences both pieces of the product. So I'm going to have 9 squared, which is 81. And now 10 to the negative 3 squared, power of a power, I'm going to multiply to give me negative 6. Now you may notice yet again that this is not proper scientific notation anymore. To be proper scientific notation, this number has to be between 1 and 10. So I'm going to move the decimal 1 over. Now, in this case, I started with a big number. Remember, when you start with a large number, it contributes larger to the power of 10. So I'm going to increase negative 6. I'm going to add 1 to that because I was starting with a large number. So it's going to contribute to that power of 10 and give me the negative 5. The other piece of scientific notation is I can give you scientific notation and ask you to write it in standard form. So remember, to do that, in number 11, I start with that 8-3, and I'm going to move the decimal over 9 times. And because it's positive, I'm going to move the decimal towards the positive numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Wherever I see holes, remember, you toss in some zeros. And now I'm just going to write it nicely. So 1, 2, 3, 4, 5, 6, 7, 8 zeros. And it helps to put those commas in. Or 12, what happens when you have a negative exponent? Well, that means just moving the decimal towards the negative values. So 1, 2, 3, 4. So now my decimal is out here, and I end up with that as my final answer. All right, and finally, oh, I forgot, I'm sorry. I have to erase my screen first. And finally, let's do a word problem of scientific notation. So the Indian Ocean covers about 28 million 80,000 square miles, and the Atlantic Ocean covers 41 million 80,000 square miles. Write each number in scientific notation. Okay. So first off, let's write both of these scientific notations. So I'm going to place my decimal after the first significant digit. So 2.808 times 10 to some number. So let's count what that number is. 1, 2, 3, 4, 5, 6, 7. For this one, look at my first significant digit. Oh, still have 7 on the brain. So 4.108 times 10 to the 1, 2, 3, 4, 5, 6, 7. So there I wrote them in scientific notation. Okay? So now that I've done that, now that I have them written out, well, now it wants to know the difference between them. So to find the difference between them, what you're going to need to do is now I'd recommend you use the calculator, okay? So to avoid any mishaps, to avoid any mishaps for this, what I would recommend that you do is go back and use the original values, okay? So to find the difference between them, I would use the original, and I need to move this up for a little bit so I can get to the 0. The original 40 1,080,000, and I would subtract off that originally written 28,080,000. So to avoid any confusion in the subtraction, I would use the standard form numbers in order to do that subtraction. Okay? And so that's going to give you a difference of 13 million. Okay? And again, I just think that that's a little bit easier to work with, the normal numbers, rather than trying to subtract in scientific notation, because that can get pretty tricky. So the difference is 13 million. And in scientific notation, what would that be? Well, put your decimal spot or decimal place after the first significant digit. You'd have to move it 1, 2, 3, 4, 5, 6, 7. So in scientific notation, that is what the difference looks like. All right, so that is the end of the review for this quiz. Thank you for watching this, and if you have any questions, please let one of us know.